All right, here we're in Chapter 2 on linear equations in one variable. Now this is Section 2.2 on absolute value equations. So an absolute value for a linear equation in one variable is given by this following. If the absolute value of x is equal to a, then we can drop the absolute value signs and we can say x is equal to a or x is equal to the opposite of a. So that means, if we had a negative a here, then we take the absolute value of that, we get a positive a. If we put in a here, we take the absolute value of that, we get a positive a as well. That's why we have two different solutions here. And a here is just any real number. Now, the absolute value is just a distance from 0. Thus, the reason we have two solutions, plus and minus a. And so, again, if we want to look at it on a number line, if we have, here's 0, here's negative a, here's positive a, what we want is the distance. So this distance is, well, we're going a units, so it's a. On here, we're going this distance. And again, it's a units, but it's in the opposite direction. And so the distance is still a, and that's why when you take the absolute value of x equals a, x is equal to either a or negative a, because we can go either direction. Now, when we do this, what happens is we're going to get a solution set. And so the solution set, we're going to put in braces. So we'll have a negative a, comma a. So that's how we're going to represent our answers with the absolute values. Now, so what we want to do is it says isolate the absolute value first using algebra and then use the definition, which is this here part here of the absolute value to solve for the variable. Okay, so what we need to do in this example here is we need to isolate this by itself on one side and get everything else to the other side. Well, that means we have to get rid of this 5. So we're just going to use our techniques we've used up to this point. Going to subtract 5 from both sides. So 10 minus 5 is 5. Now we use the absolute value definition. And so x is equal to 5 or x is equal to a negative 5. Okay. And so in the solution set, we would have negative 5, comma 5. Okay. And so, we could write it out longhand like this or as the solution set like this. Okay, let's do some more. Now this one, we have 5 times absolute value of x equals 35. And so that means we have to divide by 5 to get rid of it. And we divide by 5 here. And so then absolute value of x is equal to, well, 35 divided by 5 is 7. And so now by the definition, x equals 7 or x equals a negative 7. And so our solution set would look something like that. Now, what about this one? Well, this one, we don't have to do anything. It's all in absolute values. So all we have to do is we have to take and set 3z plus 4 equal to 10, or 3z plus 4 equals a negative 10. Okay. Well, so then we subtract 4. And so 3z equals 10 minus 4 is 6. Divide by 3. And z equals 6 divided by 3 is 2. Or subtract 4, 3z equals negative 14, divide by 3, z equals a negative 14 over 3. And again, our solution set would be that. Now, the next one, we have a lot to do. We have to do subtraction to get rid of that 1. And remember, we're doing PEMDAS in reverse order. So we do adding and subtracting first, and then we do the division, and it's multiplication next. So we'll first subtract 1. So 5 times absolute value of 3 plus 7m. And then that's 0. 51 minus 1 equals 50. Now we have to get rid of that 5, so we divide both sides by 5. So the absolute value of 3 plus 7m equals 10. Now we can say, well, 3 plus 7m equals 10, or 3 plus 7m equals a negative 10. Now we're wanting to get m by itself, so we have to subtract 3. So 7m equals 7. Now we divide by 7. So m equals 1. Here, we subtract 3. So 7m equals negative. Well, that was added together, negative 13 divided by 7. M equals negative 13 over 7. So our solution set is negative 13 over 7, comma 1. Okay, so again, it's going to be this or this, and so our solution set would be the combination there. All right. Let's pause there and we'll come back for more.